Okay, here we go. So today I'm going to talk about 12.5 tree diagrams. And the objective is we're going to learn about the counting techniques that are useful in probability theory. Next we're going to begin learning about how to use a tree diagram and tables to determine the sample space and complete probabilities. And develop in the use of fundamental counting principle. Okay, let's look at my example here. Obviously I didn't finish because we're going to finish it together, okay? So this is a tree diagram of a gender of 3 children in a family. So B is going to indicate boy and G is going to indicate having a girl. One outcome is to be completed by you, so we're going to figure out the outcomes. Okay. So if 2 parents have a child, it can be a boy or a girl. If the first one is a boy, you can still have a boy, girl. And then you can have a boy. You can have all 3 boys. You can have a boy, girl. You can have a boy, girl, boy. Boy, girl, girl. Girl, boy, boy. You guys see how I'm getting that?
Yes.
This is a G, and this is a BG. So over here is your outcomes. Your outcomes is going to be, this is like your sample space. So you just read it. And I was talking about, was it in this class? I'm not sure, but I was showing them how to read a tree diagram. So we go B, 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 and then you go B, B, G, B, B, G, and then we go
BGB.
B, G, B, right? You read the second one, B, G, B, B, G, G. Let's see, where we have it here. B, G, G, and then we go G, B, B, G, B, B, and G, B, G. Then we go to G, 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 B, and G, G, G. There should be 8 of them, right? 4, 5, 6, 7, 8, yes. And with the counting principle, that will be a 2 times a 2 times a 2. I was trying to teach you guys that last time. Okay. So I showed you how to do a tree diagram and sample space. And also I like to label it to where this is your first child, this is your second child, and this is your third child. It's much easier to read. And you just read the branches. Are there any questions on that? Let me erase all that because... Okay. Now that we have that tree diagram, find the probability of 3 children being exactly 2 boys. Did you guys all write that down? Maybe I should have kept it up there, but anyways, what was the probability? There was 8 of them, right?
Yeah.
We wrote the sample space and find the probability that a family has 2 girls. The family will have 3 children and exactly 2 boys. Exactly 2 boys. This would have been 3 boys. So this would have been a boy, girl. So what's the probability? Exactly 2 boys, 2 B's, right? All right. Well, over here we have, what was it, exactly 2 boys. We had a BBG, right?
BBD.
Exactly 2 boys.
Okay, yeah.
Yeah, you wouldn't count that. That would be 3. We would have a
Boy, girl, boy.
boy, girl, boy, right? Girl, boy, boy, right?
Yes.
Girl, boy, boy. You could have, well, I think is that about it? I think it is.
Yeah.
Exactly 2. Because you could have a boy, you could have the girl in the end, or in the middle, and the first, right? So that's 3 out of 8. Right? Okay. So the next question said, we'll do it down here, it says, find the probability that 3 children are at least 2 girls. At least 2 girls. So we would pretty much have the same thing, right?
Yeah.
So probability, what does it say, exactly 2 girls?
Yeah.
2 G's, right? Over 8. So what would we have? We could have a GGB, right?
Yes.
A GBG, or I could have had a BGG, right?
Yes.
That would be 3 over 8, 8 being the total. Sorry, I'm keep flipping back and forth, looking up confusion. So what is the percent chance of the child getting their wish? What was their wish? Well, that what they wanted was a boy and a girl. Then the other one didn't matter. Actually, that would be a boy and girl, that would be all of those, wouldn't it?
Except 2 little
Two
kids.
of them, yeah. It would be
Except for which one?
boy, 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 and girl, girl, girl.
Right.
It'll be 6 over.
So it'd be 6 over 8,
Yeah.
right? Because they wanted a boy and a girl. The other one, the other sex of the child didn't matter, so. So that would be probability. Their wishes. 1 boy, 1 girl. That would be 6 over 8. And the reason we say 6 over 8, just like you guys said, we do not want the boy, 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 or the girl, 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 but we want all the rest.
Be 75%.
Which will be what?
75%.
Well, if you divide it, it probably is, and that reduces down to 3/4. 3/4 is 75%. So if you change that to a decimal, it's 0.75, 75%. Okay. Let's go on down to here. What? I should have made that bigger. That's, anyways, I was trying to do it like Alex does, you know what I mean? Maybe I should make it. I don't know about you guys, that just looks too small. Let's make that. That, what? That just looks crazy. That just don't act right. This does not want to change. Anyways. Okay. Anyways, I was trying to make it like Alex does. So we have a box. Suppose we have a box and the cards are labeled 1, 2, 3, 4. And we have a coin that is tossed and you can get a chance of getting heads or tails. Pretty much what this is trying to say. And then she randomly picks a card from the box and records the number. So give the sample space describing all the possible outcomes. So outcomes, and we had to put it in the format of H1, which means that the heads is first and numbers 1. So go ahead and give me, what is your sample space? Remember they did that sample space. I was trying to explain to somebody that with the sample space, you don't do probability. It is probability, but you're listing them. Okay?
All of the probabilities.
But listing all the possible outcomes.
Right.
So we're doing the H first, so H1, H2, H3, H4. Now we got T1, T2, T3, and T4. If there's more than one in the set, separate them with commas. And then it usually asks you like, what's all the possible outcomes that it's going to be tails. So the event that coin toss is tails, squiggly, put your squiggly in there. So we're going to put T1, T2, T3, and T4. It's tails. Yeah, that's right. Does that make sense? I'm hoping you guys have got past this part.
Yeah.
Because I was tutoring somebody and they was like, don't I put a number in there? And I said, no, we're not. When you're doing the sample space in the event, you just list it. When it talks about probability, we're talking about fractions then. And the fraction has to be between 0 and 1, 0 being it will not occur, and 1 means it must occur. And I talked about those facts last time. So I'm going to go on to week 2. I'm going on to week 2. This is week 2. I know I was going to start next week, but the other one was a short slide. So we're going to talk about combination, permutation, and some people have got stuck here when they were doing the probability. I'm going to show you how to do it by hand, and then I'm going to show you how to do it on the calculator. And it's much easier on the calculator. We're going to use the foundation of the counting principle, and we're going to compute theoretical probabilities. I'm not sure if I told you about this, but this is called the n factorial. This is where you see a exclamation point, and you will find it on your calculator on your PRV. Okay. So anytime, I usually call it the factorial. I usually call it the countdown, because whatever the number is, you count backwards all the way to 3, 2, 1. Note to self, you read it as n factorial is n factorial. It's the number of the permutations of n distinct items. N factorial is where n factorial is n times n minus 1 times n minus 2, ... 3, 2, 1. You might need another minute to write that down. I'm just telling you what the definition is. Yeah, I think it was Jessica was asking me, what is n factorial? What does that mean?
Yeah.
I'll talk about that. Oh, wait a minute. Okay. Here's an example of what it means of permutation. So, how many different ways can 6 different cell phones be arranged on top of one another? Solution. Since there are 6 different cell phones, because once you state 1, you can't count it again. Then you put a 5, 4, 3, 2, 1. So then you just multiply them together. If you wonder what these little asteroids is, this just means multiply. Okay? I can't find the little time and I don't want to put an X, because I don't want you to get confused with the times and the X, because eventually we're going to get into that, algebra. Does that make sense? Because once you use one cell phone, you can't use it again. Then you stack another one on there. Then you stack the fourth one. Did you make copies of like what Alex?
My notes.
From here?
Yeah.
Oh, okay. Was you done writing it up, Alex? Okay. Okay, you get an example like this on there. So as you see, I put it down here. So you got a 4, this is the way Alex explains it, okay? So this is a 4 factorial and a 5 factorial and a 2. So it separates them, and that's okay if you want to separate them. And 4, 3, 2, 1. So what it's showing is that you can cancel these out. Leave you with a 4 times 3. And then we have 5, 4, 3, 2, 1, and 7 times. So we would cancel those out, and you cancel those out. Leave you with a 4 times 3 times 1 over 7 times 6, which is 12 over 42, which reduces to 2 over 7.
Now you get the 4 times 3 because the numbers are on top. And
On
then it's
top.
a fraction because the numbers are left on the bottom.
Yes, this is your numerator and this is your denominator.
Right.
That's if you do it by hand. You can also do it by calculator. So if you just get your handy dandy calculator out. I'm not gonna get my graphic one, I'm gonna get my scientific one, just like the picture is. Clear. So if I was to write this right here on my calculator, I would probably put 4 factorial, 5 factorial, parentheses, divide by 2 factorial, 7 factorial. Okay, so I put a parentheses, a 2, and this PRB, you push it, PRB, and you'll see, I think it's like number 3, it's the factorial. You guys see it? Number 3. Put the number and then you push PRB, factorial, 5, PRB, factorial. You guys get that? Then you can go ahead and push, you can push divide or the ABC, divide. Also going to tell you that your calculator can go from decimal to a fraction. So it's a 2 PRB and a 7 PRB. You got what? Okay. Then I want you, once you get that, it's going to change it. It can change it to a fraction. So you'll see where it says second, it should be like from a decimal to a fraction. Go to second. Yeah, second. And this one right here. Here. What was what you get? You guys get what I got?
No, I'm pulling up my Alex calculator because this one just tells us what's a
Sign tax every.
sign tax error. And we've had you look at it before and it told you the same. So maybe I need a different calculator.
Maybe I need to, reset it. It needs to be reset.
I can't find these things.
I can't either. I need to learn it. To that function. Oh, see, I need to learn on that one. I'm not sure about this. So did you put that in there before, like, just like I did? That's crazy. Just wondering what you guys are thinking that too. For PRB, where did PRB at?
You have to go shift. Here, shift, and then this X.
But this is different.
Yeah.
Oh, it's because it's not a TI. That's the reason I have a problem with it. What is parentheses? Let's just use ABC. Let's see if that works. Parentheses, 2, shift factorial, 7, shift factorial, close. It did say syntax error. It's not a syntax error. Anyways, your answer is supposed to be 2/7.
Right.
Mine still won't turn my decimal into a fraction. It still says the same.
It is a symbol. Then yours is for second. Where's this one? See? This one. Second is. So. See, he came from fraction, decimal, fraction.
And it's just that
You push the FD. See, mine's a little. You push FD. Mine, you push this stuff right here. This is in the fraction decimal. FD. You push the FD on your calculator. You see the FD? Those little things. No, you push second down. So you came up with this, okay? You know. Whatever you like before. So push second FD. So if the FD goes from fraction to decimal, decimal to fraction. It's your FD. If you're wondering what that is, it's a FD. Right here, FD, so it go from fraction to decimal or decimal to fraction. And it does, I don't think it has it on your Alex.
You don't see it.
You don't?
Does not.
Well, I'm sorry to hear about that.
Yeah, not even this one has it.
But you know what, it's kind of hard to do it by hand. I'd rather do it on the calculator. Plus it saves time. Just
It
saying.
can still be figured out.
Okay, now here's the definition. Look, I'm gonna draw my lines, what I was trying to cancel out earlier. Okay, so permutation, this is the order of objects without replacement in a specific order. Remember, it's on a specific order in which they are chosen is important. So remember, with permutation, order is, as you notice, order and important are in different colors. Did you guys notice that? So that's when permutation is important. me erase this over here. Let me know if you guys need a minute to write this down. This is important.
Yes.
Hint, hint. This will help you through the next part of Alex. And I'm sorry if I go a little fast.
I have done a couple of these problems, so.
You did?
Yeah.
Okay.
So I know the idea, but I need to understand it.
Well, first of all, I can show you the definition of it. I'm gonna show you the definition of it, and then I'm gonna show you how to do it on the calculator. Of course, you know, you ever had math teachers like me who'll show you the hard way first, and then show you the easy way?
Yeah.
And that's me. I'll show you what it means. Was it last class I was trying to show you about odds and what it meant? How you keep, change, flip?
Yes.
That's what it really meant. Because they wondered what happened to the 6. What happened to the denominator? So it went away, it canceled out. Okay, 1 to 5, I guess. That's what they were saying to me. You say so, Miss Jackson. Okay. Everybody got that? Okay. As we go here, this is the formula. We're going to arrange our items from N, okay? So this is permutation. Permutations. This means NPR, and it means N factorial to the N minus R factorial. That's when you're arranging R items from a total of N items. So, and your N will be your total, so it'll be your bigger number. This is just the definition of it. Okay, everybody got that? Okay. Now, here we go. I'm going to show you. So, we are doing permutations that have 5 objects taken 3 at a time. Okay? So, first of all, what is my N? N is my number total. N is what? 5. And my R is 3. So, this means 5P3, right? So it means 5 factorial over 5 minus 3 factorial, right? We'll leave the numerator the same. So what's 5 minus 3? 2 factorial, right? So then we know 5 factorial is 5, 4, 3, 2, 1. And 2 factorial is what? 2 and 1. Not 21, but 2 times 1.
So you cancel total one.
Cancel that out, leave me just the 1 on the bottom. One right here. So that leaves me with a 5 times 4 times 3. So 5 times 4 is 20. 20 times 3 is 60. Okay? Yes, I did that by hand. Ding. So then on your calculator, you push 5, and then you push the PRV button, or the one that says it shows like this, the NPR factorial, yes, NPR, and then you push the 3, and you press enter, and what did you get? 60. Did you not? Yes, I'll try that.
Yes.
Did you try it? So, is it easier by calculator or by hand? By calculator, and it saves time. Always put your big number first. If you was to put 3, choose 5, you can't choose 5 out of 3. You can choose 3 out of 5, right? If you always had to put the big number first. Remember, that's a key. You guys get it? Yeah?
I
Okay.
did on the Alex calculator, he's still 500 though. With that.
I'm trying to think of it.
Yeah, I might actually leave him.
Push five,
And
then you
shift,
shift,
shift.
shift, that one, no, this one, 2, and then the 3.
Enter.
Yeah.
You did do that one.
Yes.
It does combination permutation. But I'm gonna get combination here in a minute. So you guys got that, okay. So let's go to the next one. So I was showing you, this right here, I'm just giving you the steps on how to do it on your.
Okay.
So it's just saying that I want you to push the PRV button, and then you go down to the NPR. You press it, press enter, and you put your numbers, press enter, and it'll give you the answer. Just like I showed you. It's not that bad. But you gotta remember that permutation order matters. Because you'll get confused with combination.
Yeah.
Everybody got that? Okay. And this is also if you have the graphing one, which is the big one, you can also do it on it. And what you have to do is you have to go down to push it on, clear all that junk out. So if you was to have this, you would go down to, it says here go down, we're gonna push 5, choose 3, so 5, and you go to math, and you go over to PRB, you go down to the second one, and then we press. I don't know what you're doing here. 5, math, probability, 3. Yeah. That's what you do on this. You go to the math part if you have this. Okay? Okay. Just thought I'd tell you. Okay. Now here's an example. Now this would take you a while if you had to do it by hand. Okay. So in the finals you got 100-meter hurdles. There are 8 competitors. Assuming that there's no tie, how many ways can there be first, second, and third? Well, you automatically know this right here just tells you a little information. You don't really use the 100, right? So, does order matter when it comes to a race? Does order matter? Yes. So, we are going to put, not using 100, we're going to use, there's how many? 8? We're going to put 8, P, and how many winners? We're going to have first, second, and third. So, 3. Punch in your calculator, what do you get? What?
336.
336. Since there's no solution in order for order matters, so it's 336. But you guys were reading that one, you hated me.
No, we actually already did that.
Okay, this is how many ways that you get first, second, or third. But order does matter when it comes to any races. Also, if there's a president, vice president, or president, vice president, like with a treasurer or something, order matters too. Okay. Now next time we got batter. We got batting order. So the last group I had was a lot of sports. I taught this to high school ones, so they were like into baseball and basketball. So I thought I'd bring in some batting here. So how many ways can there be possibly 9 players? So since there's no replacement here in order and the players matter, so we would have 9, choose 9, right? And then you put it in there and you'll get 362,880. And yes, I have come up with that number.
We did too.
You did too? Okay. So how many ways is there possible of 9 players of batting orders? A lot.
Yeah.
I had a choice of all 9. Then I had a choice.
I never would think of this big number.
You never thought it would be?
That big, yeah.
Yeah. I used to think about math in different ways. You think about math different since you had my class? Yeah. The next one, we're gonna talk about combination. This is where we're selecting objects without replacement in the order in which chosen doesn't matter. Notice I got that in different colors. Order doesn't matter. This is called combination. This is the formula. So let me erase all this. Other than that formula. Combination. NCR. And this is where we have n factorial over n minus r factorial r factorial. I'm going to first show you how to do it by hand, and then we'll also do it on calculator. This is where order doesn't matter. Anybody need a minute to write that down? Okay, you're good, okay. This is also how to do it on your calculator on the 84. This is how we're going to do it on this, just like you did before. You push the PRN button. You put your number in first, then you push the PRN button, and then you choose the NCR. And then whatever number, and then you hit enter, okay? And you do have it on there, on that one, and you don't even have to push shift. Okay. Now, let's look at this example with your combination. How many combinations of 9 objects are there if there's 5 taken? Okay, so what is my N? 9. 9C 5. 5 being my R, right? Always put your big number first. So I'm going to show you how to do it by hand. So this means 9 factorial with the 9 minus 5 factorial with the 5 factorial. Right? Here I go. Got to do the count now. 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off. Okay. And then what is 9 minus 5 is 4, 3, 2, 1. And the 5 is the 5, 4, 3, 2, 1. Right?
Yes.
Then that means multiply. Okay? So I'm going to cancel that out. Cancel that out. Now we can see what we can cancel up here, right? Because we know 3 times 2 times 1 is what? 6? That cancels out that 6. And the 4 goes with this 8, would leave me with the 2, right? So now I have 9 times 2 times 7, right? All over 1, right? Let's see, that would be 18 times 7 is 6. 126. We're at 126. So if you did it on your calculator, we put 9 PRB combination 5 enter 126. Yep, I got the right answer. But it takes a while. You do it by hand. But it's so much easier on the calculator. And you know what? If you can get on the calculator and get on Alex and on my test, I'll take it. Isn't that awesome? So not only do I teach you what these words mean and formulas, but I also teach you how to use your calculator. I've had so many students come here, I didn't know how to use calculator, the basic add, subtract, multiply, divide.
Right.
And I said, well, at least you know some things. Miss Jackson will teach you more.
I never got to use it last time.
You didn't? Oh. Well, you know, I'm a certified high school teacher, so we were taught to use the calculator. But they want us to show you how to do it by hand first. So you can understand the definition of it. Okay? Okay, now, we got crayons here. Devon, is that how you say it? How many ways can Devon pick a crayon from a brand new box of 64 crayons. First of all, does it matter what's the order if he picks these crayons? Does it matter? Yes or no? If yes, then we choose permutation.
No.
If no, you say you use combination. So that would take me a long time, and I'm not gonna write all that down by hand. So we're gonna put, what we're gonna put first? Put the big number first, 64, C, 8. I would do that by hand, but I really don't have time. I'm sure you guys, so it's a really, really long number.
Yeah.
I have to erase this stuff. I get this number ways to pick a crayons. That's a lot of ways.
4 billion ways.
That is a 4,165,165,368 ways to pick a crayons. And that's a lot of ways. Questions on how I got that? No? This is supposed to take me a week to teach this. Anyways, here we are in statistics class, and we've got students that's required to complete 3 end of the chapter projects throughout the semester. If there are 10 chapters in the text, how many ways can Maggie choose which project to complete? So does the order matter? Does order matter? Does order matter?
No.
No.
So, without reading this, did you know that before you read the solution? I hope you guys knew that. You have to think about it. Order matter? Yes, no. So if it's a no, we're going to put, this is where order matters. There you go. So what we're going to put first, so we put 10. Is it C or D? Combination?
Yes.
3. So on your calculator, you push 10, combination, 3. Enter. 120. And see, I did put the answer here. I think to better my teaching, I think I'm going to also probably include you guys to do a classroom example so that you guys can work a problem on your own and I'll be checking.
Yeah.
I think it's a better way to. Okay, going to the next question. We're going to have to decide whether this is permutation or combination. Suppose we have to choose 3 colors without replacement from 4 colors. We have red, blue, green, and purple. How many ways can this be done if order matters? You'll get a question like this on Alex. This is example 4. If order does matter, what do we use? Permutation or combination? Permutation, because I put it like that. So we use order matters and we use permutation, right? So what is it? It would be a 4,
P,
3. Have you guys tried to put the small number first?
No.
Well, if you do, it's a syntax error. It'll say error. Because there's no way you could pick, there's 3 colors and you're trying to pick 4 of them? Your calculator would be like, what? I think you punched that in wrong.
How about 24?
24.
24? So how many ways can this be done if the order of the choices does not matter? 4. So that would be, how would you punch that in? 4, 4, 4, C3, and you get 4. Hope that's what you guys are getting. Yeah, okay.
The only thing that was confusing me was maybe divide, but order matters and it doesn't matter which formula was I supposed to use.
Yeah, well, now you have notes
That
that.
makes much more sense.
So you ask yourself, does order matter? If order matters, it's P. If If it doesn't matter, it's combination. Is it permutation, combination? Okay, now you come up with this one. So many people's missed this one before. So there is 14 European cities that Deborah would eventually like to visit on her next vacation. She can visit, she only has time to visit 4 of the cities, one on Monday, one on Tuesday, one on Wednesday, and one on Thursday. She is trying to make a schedule of which city she'll visit on each day. How many different schedules are there? Assume that she will not visit a city more than once. So in this example, when you visit a city, does order matter?
No. So combination of 1,000.
Actually, order does matter in this one. Don't ask me why, but you'll have a problem like this that come up on your Alex, and order does matter. So you would put a 14 P, and there will be how many you can visit? 4. PRB, and you get 24,024, right?
Yeah.
If you put combination, it'll be wrong, try again.
Yeah.
Then you know it's the other one.
Right,
I'm sure you guys, have you counted that yet?
yes.
And then you'll be like, I don't know which one to put.
Yeah.
Because I haven't taught you that yet. Okay, going to B, we have a certain committee that consists of 16 people. From the committee, we'll have a president, a vice president, and a treasurer that is to be chosen. In how many ways can these 3 offices be filled? Assume that the committee member can only hold at most one of these offices. So does order matter?
Yes.
Yes, it does. So if order matters, we're going to use the permutation or combination? We're going to use which one?
Permutation.
Permutation. So what do we put first?
16.
16
3.
P3, right? Because there's 3 offices.
3,360.
What was it?
3,360.
3,000.
3,360.
Okay. Ladies. Does this make sense?
Yeah.
Okay.
I think Shane's really impressed with this one.
He's crushing it.
He understands this.
Didn't you say, Shane, you came in math like you weren't that good in math?
Never even.
Well, you did. You have now.
I have not. I never stick with it at high school.
You never did what?
I never stick with me. Like I can't remember now.
Well, I think you're doing well in this class. Okay, now you're going to come up with one of these. Yeah, and it got a little harder. So this time, before you even look at the solution, okay? When you look at this, you're like, what? So you offer 3 appetizers, 9 courses, and 8 desserts. So a customer is to choose 2 appetizers, 2 main courses, and 4 desserts. How many ways can this be done? So you take each one, and as you see here, I took them by bins, okay? I took first one by the appetizers, right? There's 3 of them to choose, and they chose 2. 3 choose 2.
So you have to do it 3 seconds.
Then you go into the main courses, and there's 9 of them, 9 choose 3. Then I took the desserts, and there are 8 desserts, 8 desserts choose 4. Then you multiply them all together, then you come up with your answer.
So you're gonna do 3 different ones.
So this you might want to take notes of,
Yeah.
or take a picture or something. Because you'll get something like this, and then you'll be like, I cannot get this. I'll move Eddie away from that. Because I believe there's one on this on Alex, like it. And you'd have to take each one by. I think there's one whole section with just this. Last semester I was teaching them, they said, help me, Miss Jackson. I said, well, I'm gonna come up with this and I'm gonna make my own table. Even I look at the explanation of Alex, and I said, well, I kinda like my table better than Alex did. Some of the explanations I go, Did you guys ever do that when you was looking at the explanation, you go, what?
So you would just do 3 times 84 times 70 at the end?
Yes.
Yeah.
Yep, that's what it is down here. I would have made it bigger, but you know, we messed all my, trying to get all on one page.
Yeah, I missed that one.
Yeah. So this is the, how many ways that a customer can choose 2 appetizers, 3 main courses, and 4 desserts. Does that make sense? So if you have to, on my paper, I would have to make a table so that I would figure out this.
So why is it combination and not fermentation? Why does the order not matter?
Because you're choosing food. It doesn't matter which order you choose an appetizer.
Okay, so no matter.
It doesn't matter how I choose those 3 appetizers. Now, if we were talking about election officers or a race, order does matter. But if I'm talking about if I had like 5 apples and I could choose 3,
It doesn't matter.
doesn't matter. Or if I have 10 crayons and I need to choose 2, it don't matter. Order doesn't matter, does it? No. Usually in food, it doesn't matter. You might want to test my theory, but unless it says, it has to say it in the problem that, which it wouldn't be combination in those. You know how one was like, this painting has to go first, the second painting has to be this, to be alternating, then it's not combination, you're gonna have to put, I made the lines, you remember that? Did I teach that part?
I've done that. So I don't know if I've done it here.
I might have,
I have
should have.
notes on it.
Your notes on it, okay. Questions on this? I'm glad we're holding. Okay. Now we got some more, and this is kind of confusing too. You'll get to this problem. So we have a university student is selecting courses in the next semester. He can choose 6 science and 10 humanities courses. In how many ways can he choose 8 with 2 being fewer? 2 being fewer these science courses. So 2 it'd be fewer than 2. So he can choose 1 or he can choose none, right? So if he chooses 1 science, if he chooses, so it has to be a total of 8. So if he chooses 1 science, 7 of them has to be humanities. So if he chooses no science, then all 8 have to be humanities.
No, because it has to be fewer than 2.
Has to be fewer than 2, and I list them here. So this right here, so then you would have 6, so right here, you have this right here, goes with this, okay? So that means 6 sciences, choose 1, 10 humanities, choose 7, plus, then you come down here, plus 10 humanities, choose 8. Yeah, see how I did that?
Trying to figure out how to write it.
Okay. And there will be one like this on there. Alex, you look confused. What are you thinking?
I'm just reading.
Okay. But this right here, this solution is just my thinking. That's the reason I said if he chooses one of those, so that would be 6 sciences, 1, 10 humanities, choose 7.
So why do you plus 45% also?
Because it comes up with the right answer.
So would you put that in your calculator, like 6C1 times?
Yes. Yes.
Okay.
You can do that on your calculator. Did you hear her question? You can put this in your calculator, just like this, and it will come up with this. Or you can figure out what they are, and then do it.
That's what I was about to ask, you can just do them each individual.
You can do it each individually, or you can just all at once.
I think individually will be better for me.
Well, I think individually it makes more sense. Well, I think the reason you would probably add is because in how many ways can he choose 8 if fewer than 2 must be science? Fewer than 2, that means 1 and a 0, right? So this is considering 1, and then you add on this one, right?
Will it always be add?
It will always be added in this type of problem. Because these are, you can think of these as like 2 different cases. This is the first case, we'll apply them together, add it on to the second case. You guys can go ahead and try this out. Did you get the answer I got? But I did it individually so I could show my steps.
Where did you come up with the 10 combination to 8 that equals 45?
Okay, right here. Right here, there's 10 humanities.
Okay. And 8 courses.
There's 6 science, okay? So we know 6 choose 1. We know 6 choose 1.
Right.
6 choose 1. And we know 10 choose 7. 10 choose 7.
Okay.
Because these two have to add up to the 8.
So the third one is if you didn't pick any sciences.
Any
That's where
science,
you
right.
pick 10.
That's when you just put 10 choose. Because if you choose none of the sciences, it's 0. Did you guys try that one?
Right.
So if you choose 6, choose 0, I think it's 0.
Right.
Have you tried it?
Well, I was just typing it in, that's why I wanted
Yeah.
to.
That's when, if you're wondering what happened to the sciences, there's no science. What, how many ways?
Because he chose all.
So there's 6 sciences, then I choose none of them. How many ways?
None.
0. Questions? I'm not sure if you guys are like afraid to ask or. Okay. Make sure I would write out the cases, then figure out how much you done here. Some people just want to do this and come up with a solution. That would be awesome if you can do it,
Right.
but I have to write it down. There's lots of times I want to just do that. If I'd done that, I would not have got my degree. I'll tell you that. I did a lot of writing. A lot. Okay, so I'm gonna erase this off. Okay, what's the possibilities of drawing with replacement? This is with replacement, okay? So we have a box that contains 7 pink and 8 white balls. 5 balls will be randomly chosen from the box in succession with replacement. That means once I pick one out, I put it back in. That is After I said that, return it back to the box, that's just what I said. So what is the probability that all 5 drawn from the box are pink? Okay? Round your answer to 3 decimal places. Have you guys got to this part yet? So this means, so I'm gonna ask you, if I drew the first one, how many pink am I in? What's my probability of me choosing the pink one? 7. How'd you get 7?
There's 7.
There's 7 pink out of, let's do together, 15. So if I'm replacing it back, there'd still be 7015 times 7015, 7015 times 7015 times 7015. That's the reason you put 7015 to the 5th power. Does that make sense? Returning the ball to the before the next draw makes all of them independent as drawn is affected the other draws. So we would say probability that all 5 balls drawn are pink will be 7 over 15. That's with replacement. Without replacement, we would do, this would be a 7, and then a 6, and then, you know, once one's taken out. So this is with replacement. Questions?
I'm trying to figure out how to make it go up there.
Put your little, let's see, on that one, it's different. So you have the,
Like this little, right here. Is that good? Any of those?
yes. See, it's approximately, see that little squiggle means approximately. You guys ever,
Yeah.
didn't know if you've ever been told that. Little wave is approximately. 0.022. Give you a minute to jot that down. And just think I was gonna do this next week. It's okay. I could do this. I'll just stop right there. How about I just stop right there? Because it'll give me something to teach on Wednesday. I don't wanna run out of material.